In this video, we're going to cover the exponential distribution. So we'll start with the exponential probability density function is f of x is equal to lambda times e raised to the negative lambda x, where e is approximately the value 2.71828. X is our variable, and y is the mean number of arrivals per unit, usually per unit time, that we'll be discussing in this section. So what does this mean? Well, what does this graph actually look like? Let's draw that down. This function will have the shape drawn here, and it essentially represents that given our variable x along this usual x-axis, we have our probability density function height here. So what do we do with this information? What does this usually model? Well, we might think of, if we know the mean number of people who arrive at a bank over a certain time period, then you might ask yourself, well, what is the likelihood of somebody arriving in the next 5 minutes? If you want to ask something like that, this kind of a function can help us solve that problem. And specifically, if we want to know the chance that somebody arrives within the next 5 minutes, we will find the x value that corresponds to the next 5 minutes. And we will find the area under the curve up to that point. Well, how do we do that? We do that via the following function. So the cumulative exponential probability function is, and this is given by the probability that the arrival time is equal or less than some value x, and that is 1 minus e raised to the negative lambda x. So this is our function that we're going to be using for every single problem that we do in this section. And the last bit of this video is just to run through 1 or 2 examples. So example 1 here is if lambda is equal to 29, what is the probability that the arrival time is, and then a is going to be less than x equal to 0.1. Well, we do that using the formula we just had, which is the probability that the time is equal or less than x equal to 0.1. This is given by the formula 1 minus e to the negative 29 times 0.1, which is 1 minus e to the negative 2.9. And then if you wish to have that in decimal form, you can just plug that into a calculator or your computer. Let's do a related question. What if we ask that, what is the probability that it will be greater than x is equal to 0.1? Well, greater than 0.1 is just the complement to the previous question, less than 0.1. So this is, the answer here is 1 minus the probability that time was equal or less than 0.1, which is 1 minus the previous probability, which was 1 minus e to the negative 2.9. 1 minus 1, that goes to 0. Negative minus a negative, minus a negative here makes that a positive, so this is just e to the negative 2.9. And again, you can just plug that into a calculator if you want the decimal version. Whoops, I said 2 there. I meant B and C. The last example we'll do of this type is, what if we were asking between x equals 0.1 and x equals 0.3. Well, to do that, we can calculate the probability that that the arrival time will be less than 0.3, and we can calculate the probability that it'll be less than 0.1 and subtract this probability from this one. So in other words, this is the probability that time is equal or less than 0.3 minus the probability that the time is equal or less than 0.1. Well, the probability that the time is equal or less than 0.3 is 1 minus, just plugging this into our formula, 1 minus e to the negative 29 times 0.3. And we're going to subtract off the calculation we did at the beginning, which is 1 minus e to the negative 29 times 0.1. And you can simplify that first if you wish, and then plug it into the calculator. Just plug it into the calculator as is to find a decimal version. We're going to do a very similar example here for the last example, but I just want to phrase this in terms of a real-world application. So let's suppose that we know the telephone calls arrive at an information desk at a rate of 25 per hour. The question is, what is the probability the next call arrives within 12 minutes? One thing we need to be careful of is our first information, the lambda, is 25 per hour, but our x, 12 minutes, was given in minutes. So x equal to 12 minutes, we then need to convert to out of hours because that's what our lambda was given in. So 12 out of 60 would equal 1/5 of an hour, or 0.2. So our x is actually going to be 0.2 here. And x can range from 0 to infinity, so you can allow x to be bigger than 1 in this case. What if we wanted to know the probability the next call arrives within an hour and 5 minutes, right? Which would be, if we're in units of hours, so an hour and 5 minutes would be bigger than 1. And we could ask that question. But in this particular example, our x ended up being less than 1 again, and in particular, 0.2 hours. So let's go ahead and plug that in. So the question is, what is the probability that the arrival time, or the when the next call will arrive is equal or less than 0.2 hours. Well, this is 1 minus e raised to the negative, lambda was 25, x was 0.2, so this is 1 minus e to the negative 5th power, and we plug that into a calculator if we need to know the decimal form. And that's it for this video.